Hey guys, um, just wanted to make a quick video for the coursework 2 solutions for Math 3272. Sorry that they're so late. I hope this is maybe a help for you studying for the final exam. Let's go. This is the first question. It says we have a group G acting transitively on a set X. That means essentially that there's, in the group action, there's only one orbit. Okay? And now we have a subgroup of G, and we have to find the size of an H orbit. Okay, the orbit of X, but we're only using like elements of H, not all of G. Okay? And then I put like some rules, like you have to write it in terms of a few other quantities. Okay. The solution is just to use the orbit stabilizer theorem for G and to use it again for H. So the orbit stabilizer theorem says that the size of the orbit is the group index of the stabilizer in the group. Okay, so since there's only one orbit in X, we have the size of the orbit is all of X, and that's equal to the index of Gx inside G. And remember, Gx is all the elements of G, such that Gx equals X, and Hx is going to be all the elements of H, such that Hx equals X. Okay, so okay. Okay, and so the size of X is the index of Gx and G. The size of the H orbit is the index of Hx and H. And kind of our thinking is like these three are like known quantities. This one, and this one are known. And this is the one that we want to solve for. So let's try divide this by this and see what happens. We get the size of the H orbit divided by the size of the G orbit equals the index of Hx and H divided by the index of Gx and G. Okay, now any index can be written as the size of the subgroup divided by the size of the subgroup. Sorry, the size of the group divided by the size of the subgroup. Here we go. Okay, and the same for the size of G divided by the size of Gx. Now we just do a little switcheroo. The denominator of the denominator is really like the numerator. So we're just moving Gx, size of Gx and size of H are both in the numerator, but we'll just like switch them so that it looks nicer. And then multiply both sides by the size of X, and we get this relation. Okay, so the next video is going to be on question 2.